All right, this is for the University of St. Thomas, Math 005, J term. This is Lesson 8, Part 1. And we're going to be talking about the process of figuring out the relationship versus, or a relation versus a function. So what it boils down to is that for a relation, every input that we have, or every x that we have, there is at least one solution or output. All right, so you can have more than one, but you have to have at least one. Now, in the case of a function is a subset of relations, and in that case, there is exactly one solution. All right, you can't have a second one involved in it and have it remain a function. So let's go and take a look at some examples here. If you want to take a look here, we have an input of 0, right? And let me go ahead and I will highlight some of these. There we go. Not sure why this is not wanting to cooperate, but we'll go with it. All right, so in this case we have a 0, a 2, a 4, a 6, and an 8. In none of these cases do we have more than one solution, right? There's no 0, 0 and a 0, 1. It's just 0, 0. So in this case, because each one of these has a unique output for each input, this is a function. All right. In this case, I have 0 and 5, and now I have a 0 and negative 5. I have two different numbers. Now, granted, they're the same distance from 0, but 5 and negative 5 are two definitely different numbers. So this is not a function. This is strictly a relation. All right. And in this case, if we scroll down a little bit, we're asked to determine what the values are. I'm going to put in, I'll do one of these and you guys can do the rest. I'm basically going to try and do one of each just to kind of show us where where we want to go with these. So in this case, I have a function of this thing, right? This square root of 3x plus 2. And we're told by the number 10 inside the parentheses that we are using x that's a 10. All right, so we're going to go ahead. I'm going to rewrite that. So we have our square root of 3 times 10, which is going to get me 30, plus 2. So my square root here becomes square root of 32. And if you think about that I have 16 times 2 happening here. And 16 is a perfect square. And I'm going to pull these apart so that you can see kind of what's happening and how we go about addressing this. All right, 16, square root of 16 is a 4. So we're going to pull that 4 out from underneath the square root. Right, now that 16 is now a 4. And my square root of 2 still gets drawn along. It doesn't disappear. I still have to address that. So it's 4 square root of 2 is our solution there. And you would do exactly the same thing for the 14 over 3 and for the negative 1/3, right? So you're going to do that in each of those cases. I want to go ahead and do one here. And actually I'll do 2 of them because this looks a little intimidating when you get to D, and I want to make sure that it's clear what's happening there. All right, so here I'm told g of 3. I'm going to put 3 in place of this x. All right, so I've got 3 over 3 minus 4, so that becomes 3 over negative 1, which is really just a negative 3. All right, in this case, we're going to substitute in a b plus t in place of that x. We're not going to be able to get to a single number because we don't know what b or t are, but we are going to go ahead and put that in there. So I'm going to have a 3 over the quantity of b plus t minus 4. And that's as good as we can get it, right? We don't know what b or t are, but that's as much as we can do and as much as we need to do. So we also have a case here where we need to be mindful of if this thing can go to 0 in the denominator. If it can go to 0, then we have a problem. And that means that the domain, remember our x's are the domain, there are places that the domain does not work. It fails, okay? So if I were to put in a -2 here, this would make this whole thing go to 0, and I can't divide by 0. Now if I were to put in a 2, a +2 here, this whole thing would also go to 0. So I have to specify that x cannot equal 2 or -2. It can't be either one of those. Now they want us to express this in interval notation. Interval notation, remember that's going to have our -infinity in this case, so because it's all numbers other than the 2 and the -2, right? So I can go to -2, from -infinity to -2, and then I'm also going to have my -2, and again I'm doing parens here because I'm not including the -2. So my -2 to +2, and again I'm going to use a paren, not a square bracket, and then I'm going to go one more. I'm going to have my 2 to +infinity, and that is my solution. It's basically all real numbers in with the exception of -2 and 2. If we go ahead and take a look at this next one down, I'm going to point out that ultimately, and I'm going to let you guys solve this, but ultimately this thing here has to be positive. It can be 0 or positive. So it must be greater than or equal to 0. All right, that it can be 0, but it can't be less than 0. It can never be negative under that square root and still have it work. So in this case, we were going to go ahead and you would solve for what it would make it be 0, right? So if I have 5x plus 1, set it equal to 0, and then solve, that will tell me what my x, what's the smallest number my x can be. And after that, it's got to be everything greater than that. You just are going to use your interval notation to determine what that is. Okay? Again, I'm going to leave that for you guys to solve. And I'm going to talk briefly about what's called the vertical line test. In this case, I have a function, right? We have a curve at least, and we're trying to determine whether it's a function or not. So if I drop a line, a vertical line here, everywhere along here, I can pick any place, and I can, and I can drop a vertical line, and that vertical line will only cross through my curve once. All right? It's only going to pass through my curve once. And because that's the case, we're able to say that this is a function. It passes the vertical line test. If it only crosses once, you've got a function. All right? So in this case is a function. Now, in this case, if I were to draw a vertical line here, right, we could mislead ourselves into thinking that this is a function. Because at that point, I only cross the line once, right? But the second I move over to the right a little bit, now I've crossed twice, right? I'm going to I keep crossing more than once. The first time I cross more than once is enough. I don't have to keep testing after that. But the moment I cross more than one time, that stops being a function and becomes just a relation, right? It's a relation only. It is not a relation that happens to be a function. So you can take a look at these and determine what is what. All right, some of these are going to be relations, some of these are going to be functions, and I am going to say that that's good enough for right now. Go ahead and try that out and find your solutions. And if you have questions, be sure to ask on the next day we have class.